Even a cursory glance at the history of the Cold War shows that ideology played a prominent role. The vast number of isms that show up make that extremely clear. Marxism, Stalinism, communism, capitalism, personalism, racism, and so on and on. But there was one ism whose rise to prominence began during the Cold War, and whose major early proponent, one of its earliest champions, was born of the Cold War itself. I'm your host David, and today we're going to be looking at how a series of Alaskan nuclear tests on Amchitka Island in the Aleutians helped spawn the modern environmental movement. This is the Cold War. In November 1971, a 5-megaton bomb, roughly 400 times the explosive power of Hiroshima, detonated a mile beneath a fog-shrouded island at the ragged edge of the North Pacific. The ground heaved like a living thing. Lakes sloshed out of their basins. Cliff faces calved into the sea. And hundreds of miles away, people who, a month earlier, had never heard the name Amchitka suddenly knew it as the place where the United States was willing to shake the earth in the name of security. But Amchitka became something else, a spark for a new kind of environmental politics, the origin point for Greenpeace, and a case study in how Cold War ambition left behind problems measured not in years or even decades, but in half-lives. Today we're traveling to the Western Aleutians to see why this remote strip of tundra became a nuclear test site, how 3 underground detonations, Longshot, Milro, and Cannikin, were engineered and justified, what they did to the island's geology and wildlife, how indigenous communities and activists fought back, and why, half a century later, scientists are still sampling kelp, mussels, and fish in waters that look pristine until you read the lab results. So, Amchitka sits in the Rat Islands group of the Aleutians chain, a 40-plus mile sliver of boggy lowlands and rugged volcanic ridges hammered by the North Pacific. Storms roll through like freight trains. Fog is more common than sunlight. Beneath the island, the Pacific Plate dives under the North American Plate. This is an earthquake factory. Magnitude 8s are not strangers here, and the landscape wears the scars of shifting crust, landslides, and battered shorelines. For all that violence, the seas around Amchitka are astonishingly alive. Cold, nutrient-rich currents feed plankton blooms that feed everything else. Pollock, halibut, cod, salmon, seabirds in careless wheeling flocks. Whales tracing ancient routes, sea otters working the kelp beds like pearl divers. The island today lies within the Alaska Maritime National Wildlife Refuge, and on the right day, it looks like nothing more than wind, water, and birds. People have known it far longer than maps have. The Unangach Aleut people moved through this seascape for millennia, hunting marine mammals, fishing, gathering bird eggs along cliffs that test the nerve of any climber. Russian colonizers arrived in the 18th century with guns and a limitless appetite for sea otter fur. Violence, disease, and forced relocations followed. By the early 19th century, Amchitka's small community was gone. When the United States bought Alaska from Russia in 1867, Amchitka came along as an empty ledger entry. Empty only in the sense that no permanent residents lived there anymore. The Second World War put Amchitka back on the strategic map. After Japan seized Attu and Kiska in 1942, the US military landed on Amchitka in early 1943 and built a forward airbase within weeks. At its peak, more than 15,000 personnel called the island home, living in mud and corrugated huts. At the end of the war, they left behind runways, roads, fuel dumps, and debris, along with introduced rats that would earn their own destructive footnote in Aleutian ecology. The base wound down after the war, and the island went quiet again. Quiet, but changed. After the 1963 Partial Test Ban Treaty banned nuclear explosions in the atmosphere, outer space, and underwater, the nuclear weapons establishment needed places to test underground. Nevada was the workhorse, but it had its limits. Very large devices risked venting radioactive gases into the air or breaking containment, and as the Cold War moved into its ABM phase, anti-ballistic missiles, the United States wanted to prove warheads at yields Nevada just couldn't handle. Amchitka checked the right boxes. It was remote but American, with no civilian population to evacuate. It had a military history and an implicit, if troubling, precedent for federal use without local consultation. And it offered something else scientists wanted, a geologic setting that would produce clean seismic data. If you're going to prove that you can tell the difference between an underground bomb and an earthquake anywhere on Earth, it helps to fire a bomb inside a place famous for earthquakes. In the mid-1960s, the Atomic Energy Commission and the Department of Defense dusted off earlier ideas for using the island and began planning what would become 3 underground tests. 2 were about seismic discrimination, calibration, and proving the island could tolerate a gargantuan shot. The 3rd would be a proof test for a specialized anti-ballistic missile warhead, the W-71, designed to intercept incoming Soviet ICBM warheads in space with intense X-ray radiation. In a decade when both superpowers were flirting with missile defense systems, a working Spartan warhead wasn't just physics, it was negotiation leverage. The first detonation on October 29, 1965 was codenamed Longshot. At roughly 80 kilotons, which is small by Cold War standards, although certainly not small to anything living nearby, it went off at a depth of a little over 700 meters. Longshot wasn't about testing a weapon so much as testing our ears. Scientists wanted to refine the fingerprints of underground explosions, and an island that regularly produced its own natural earthquakes was a perfect place to practice separating signals from noise. The shot contained cleanly, meaning nothing leaked out. The sky did not glow green, the island did not crack in half. And that was the point of Longshot, to establish a baseline, gather data, and then move on. 4 years later, on October 2, 1969, the AEC fired Milro, a 1 megaton device lowered about 1,200 meters into the Earth. If Longshot was a hearing test, Milro was a structural stress test. Engineers and geologists needed to know whether the island's rock could absorb a shock 1 order of magnitude larger, still without venting radiation, setting off major earthquakes, or pushing a wall of water towards Alaska's coasts. In an internal phrase that later slipped into the press, Milro was, quote, testing the island, not the weapon. The ground shook hard, instruments recorded a seismic event in the high 6s. No catastrophic tsunami followed. None of the nightmare scenarios materialized. The AEC believed that they had their green light. By then, however, the island was no longer an obscure coordinate on a classified map. News stories filtering out of Alaska. Scientists' warnings about tectonics and a steady drumbeat of anti-war sentiment were converging. In Vancouver, a small group calling itself the Don't Make a Wave Committee started asking awkward questions. They would soon adopt a new name, Greenpeace. The 3rd test was the reason the other 2 existed. On November 6, 1971, the United States detonated Cannikin, a 5 megaton shot lowered roughly 1,800 meters underground. The device was the W-71, the heart of the Spartan anti-ballistic missile. If detonated in high space, its intense X-rays were meant to fry incoming re-entry vehicles rather than blow them apart with blast and shrapnel. It was an odd descendant of an age that had already dreamed of peaceful nuclear explosions for digging canals, a hyper-specialized, supposedly cleaner nuclear device whose logic made sense only in the rarefied paradigm mathematics of missile defense. Cannikin was an engineering leviathan. Crews drilled one of the deepest shafts in the United States, instrumented it with hundreds of meters of sensors, and lowered the warhead in a missile-sized canister connected to trailers topside by miles of cable. And because the National Environmental Policy Act had just become law, Cannikin was the first nuclear test to go through a full environmental impact statement. The ink on NEPA was hardly dry when lawyers were citing it to demand answers. What happens in a magnitude 7 seismic event on an island already prone to large earthquakes? What about tsunamis? What about wildlife? What about radioactive groundwater? Court filings flew. The case went all the way to the Supreme Court. Just hours before 0 hour, the justices declined to block the test. Meanwhile, out on the storm-riven Pacific, Greenpeace's boat, the Phyllis Cormac, fought seas and time to reach Amchitka in a bid to bear witness. They didn't make it to the exclusion zone, but they didn't have to. Cameras were rolling, and a new model of environmental protest, part publicity, part sacrament, was being born even as the warhead's firing sequence ticked down. Cannikin's detonation registered like a moderate earthquake, about magnitude 7, and then the weirdness began. Observers described the island's surface undulating in slow motion. 15-foot pressure waves rippled through saturated soil. Ponds and small lakes sloshed like bathtubs on the deck of a ship. Within 48 hours, the roof of the underground cavity collapsed and the ground sagged, leaving a subsidence crater more than a mile wide and shallow as a tidal pool. Among parts of the coast, the land lifted, permanently changing the tidal zone. The sea boiled foam where cliff faces had dropped away, and living things paid. The shockwave likely burst the lungs and ruptured the ears of hundreds, probably thousands of sea otters. Seabird colonies near the site experienced die-offs and abandonment. Fish in nearshore waters suffered an invisible trauma that didn't make it into photographs. Now, what didn't happen mattered, too. Monitors detected no significant venting of radioactive gases. The worst-case tsunamis did not arrive. Volcanoes did not wake up. Godzilla did not emerge from the ocean to destroy Tokyo or even Anchorage. On a narrow, technical scorecard, Cannikin was a success. It validated the warhead's performance envelope. It produced clean data. It did what it was supposed to do. And yet, in strategic terms, the world was already moving. Within a year, Washington and Moscow signed the ABM Treaty, limiting missile defenses to a token force. The Spartan system the W-71 was built for would be deployed briefly, then curtailed, then cancelled. The United States never fired another nuclear device on Amchitka. Okay, so then what? Well, underground nuclear testing is often framed as the safer alternative to the coral bleaching, fallout-spewing, bikini-bottom-forming spectacles of the 1950s, and on one level, that is true. No mushroom clouds blew over the Aleutians, but burying a device does not make it disappear. It just changes the problem. Each detonation vaporizes rock and leaves behind a cavity lined with melt glass, a tomb of sorts filled with fission products, activation products, and whatever plutonium and americium the physics left unconsumed. Those radionucleotides can bind to minerals, get trapped in glass, or ride groundwater pathways out to the sea. Which one of these happens depends on geochemistry, fracture networks, and time. In the short term, the environmental damage was visible. Cannikin rearranged the Earth's surface above it. It killed wildlife through the shock alone. The test program had required the construction of roads, pads, and a temporary company town of trailers and tanks. Fuels leaked. Some waste was buried, some was hauled away, and some was simply left to the elements until later waves of cleanup efforts. The long term, however, was always going to be a quieter question. Would the island's groundwater carry radionucleotides to the nearshore environment? If so, when and where? And could you tell the difference between a whisper of leakage and the global background of radioactive dust already present thanks to earlier atmospheric tests half a world away? For years, the answer was essentially, we don't know. Sampling programs in the 1970s and 1980s were sporadic and often focused on land rather than the sea. In 1996, Greenpeace sent an expedition that reported traces of plutonium and americium in certain surface samples. Numbers too small to panic over, but significant enough to demand better baseline science. The Department of Energy countered that the detected amounts were consistent with global fallout, not local leakage. The stalemate served one purpose: it forced a serious, modern look. In the early 2000s, an independent consortium of university researchers working with the Department of Energy and Aleut community stakeholders built hydrological models of the island and sampled what matters to people: food. Teams collected mussels, sea urchins, kelp, bottom fish, and sediments around Amchitka and at a reference site elsewhere in the Aleutians. The results were reassuring, but cautious. No significant elevation of radionucleotides was found in the seafood compared to the reference site. The working conclusion: if leakage was happening, it wasn't yet reaching the food web in a measurable way. But the scientists underlined a crucial caveat. The source term, the exact inventory and chemical form of the radioactivity in the cavities, remains classified. Models are only as good as their inputs. In a place shaped by earthquake energy, a small change in fracture networks could matter. The recommendation was plain: keep watching, keep sampling, keep your baseline current. That monitoring has continued. The Department of Energy's Office of Legacy Management now treats Amchitka as a long-term stewardship site. Interagency teams, including the U.S. Fish and Wildlife Service, Alaska state scientists, and Aleut representatives, periodically return to collect water, sediment, and biota, and to check on less exotic contaminants as well. PCB residues from old lagoons, fuel from rusting drums, unexploded ordnance, the sort of detritus often left behind from abandoned camps. The island's invasive rats, introduced during the Second World War, still haunt seabird colonies. Even in a wildlife refuge, history doesn't always let the land heal on its own schedule. Amchitka had no permanent human residents during the nuclear tests, but that does not make it a human-free story. People in communities like Atka and Unalaska eat what the sea provides, and if radionucleotides ever ride groundwater to the near shore and enter the marine food chain, those communities become the first truly exposed. That fear is not paranoia, it's risk calculation. It's why Aleut organizations have insisted on a seat at the table in monitoring plants and on sampling species that people actually consume. It's why clean environment equals clean food isn't just a slogan in the Aleutians. There's also a political truth to reckon with. Amchitka's availability as a test site is entangled with wartime displacements. In 1942 and 1943, the US government evacuated many Aleut villages and moved families to internment camps in southeast Alaska, where disease and neglect killed far too many. Some villages were never re-established. The absence of a civilian population on Amchitka in the 1960s is not a natural fact, it's part of a longer story in which national security regularly treated indigenous homes as empty space. If Amchitka revealed those old habits, it also accelerated new ones. Cannikin was the first nuclear test to undergo a full environmental impact statement. NEPA, the National Environmental Policy Act, turned the idea that defense projects were beyond scrutiny into a fond memory. Lawsuits or no, the very existence of a public process forced the Atomic Energy Commission to answer questions it had long brushed aside. When the Supreme Court declined to stop Cannikin, it did not erase the lesson. Environmental law had entered the war room, and it wasn't leaving. And then there's Greenpeace, the little committee in Vancouver that rechristened itself with two words, green for the environment, peace for the obvious, would grow into the most recognizable environmental NGO in the world. Its tactics, non-violent confrontation at sea, spectacular imagery, moral theater, were honed on a voyage that didn't reach its destination, but still changed the conversation. From Amchitka, the organization sailed, figuratively and literally, toward French test sites in the Pacific, toward whaling fleets, toward a global role that made it easy for detractors to sneer and just as easy for supporters to donate. However you judge Greenpeace, its origin story is inseparable from an island whose name few knew in 1970. No nuclear devices detonated on Amchitka since 1971. In the years after Cannikin, the island was transferred to the Department of the Interior and folded into the Wildlife Refuge System, with carve-outs that allowed access roads and monitoring sites to remain. The Army Corps of Engineers, under a program dealing with formerly used defense sites, scraped up what it could: fuel tanks, derelict buildings, contaminated soils. The Department of Energy sealed test shafts and developed long-term surveillance plans. But the island is not a museum of a single moment. In the early 1990s, in a brief post-Soviet wobble of strategic thinking, a large over-the-horizon radar was planted on the tundra, then abandoned. For the most part, the policy now is inspect, sample, model, repeat. The roads punched through the tundra in the 1960s still carry the occasional ATV loaded with coolers and sampling gear. Refuge managers keep people out for reasons that would be familiar at any former range. Unexploded ordnance is nothing to trifle with, and isolation is a good way to keep ecosystems from absorbing more damage. There's a difference between silence and resolution. Amchitka is quiet not because it's finished, but because its legacy is now the work of scientists and stewards rather than engineers and war planners. Climate change complicates that work. As precipitation patterns shift and permafrost's edges retreat northwards, groundwater behavior changes. The same fractures that shrugged at 1 megaton in 1969 might, under different conditions, behave unpredictably in the future. A very large earthquake could open new pathways from cavity to coast. Long-term stewardship isn't a euphemism, it is the only rational response to a problem built to outlast the careers of everyone charged with watching it. Amchitka is a Cold War Rosetta Stone. Read it and you can decipher how strategy, technology, law, indigenous sovereignty, and ecology, things we like to keep in separate boxes, press into each other until the lid doesn't fit. It's a lesson in the costs of power, and it asks whether we are willing to steward the problem we created for longer than it took to create them. We hope you've enjoyed this episode, and to make sure you don't miss any of our future work, please make sure you're subscribed to our channel and have pressed the bell button, currently setting up a secret underground lair in the far north of a remote island chain, plotting a series of tests designed to plot world domination. Please consider supporting us on Patreon at patreon.com/thecoldwar or through YouTube membership. We can be reached via email at thecoldwarchannel@gmail.com. This is the Cold War Channel, and as we think about the Cold War, please remember that history is shades of gray and rarely black and white.